All right, like I said, today we are going to talk about 9.6a. We're going to talk about our inverse trigonometric functions. So our trig functions, our regular trigonometric functions, are sine, abbreviated SIN, cosine, abbreviated COS, and tangent, abbreviated TAN. We also had little sayings to help us remember each of the ratios. So we had SO, standing for sine, is opposite over hypotenuse. Ca, standing for cosine, is adjacent over hypotenuse. And TOA, which is tangent is opposite over adjacent. All right, so our inverse trig functions, they look very similar to our abbreviations, only they're going to have a little, an exponent of -1. Okay, so we have sine, cosine, and tangent raised to the -1 power, and that is our inverse here. Okay, so we are going to go ahead and just jump into some examples using a calculator. So these are just going to be calculator examples. So our regular trigonometric functions, what they do is they tell us that from the angle, the ratio that we are supposed to get, the fraction as a decimal. Okay, what the inverse functions do, they actually undo that and tell us our original angle. Just like addition and subtraction undo each other, or multiplication and division undo each other, the trig functions and the inverse trig functions are going to undo each other. So our goal with this is to find the angle that we started with in degrees. All right, so our first example is that the tangent of some unknown angle of A is equal to 3.5. So that means that our ratio of opposite over adjacent gave us the decimal 3.5. And to find our missing angle, we're going to use our tangent function. So I'm going to bring in my calculator here, and how we do it on my calculator is we have to hit the second button and then the tangent button, and you can see that we have tangent raised to the -1, and then we type in our decimal here. I'm also going to make a video about how to do it on just the calculator on Google as well. We can see here that we get 74.05. We're going to round to 2 decimals here. All right. So 74.05 degrees. Next, we have the sine of an unknown angle of A is equal to 0.55. All right. So again, the ratio of opposite over hypotenuse gave us the decimal of 0.55. And to get our angle, we're going to have to hit second and then our sign and then type in that decimal, close our parentheses, and then hit enter. And we can see here we get 33.36. Then we have a 7 here, which is greater than 5. So we're actually going to round up this 6 to a 7. All right, so we have 33.37, gosh, 7 degrees. Okay, our third example of this, we have our cosine of an unknown angle of A is equal to 0.45. So again, the ratio of adjacent over hypotenuse gave us the decimal approximation of 0.45. So we're going to use our inverse function to go ahead and find the angle. So again, hitting second, hitting our cosine, and then typing in that decimal, closing our parentheses, and then hitting enter. We get 63.25. And since the number after the 5 is greater than a 5, we're going to round up that 5 to a 6. So we have 63.26 degrees. All right, but we do have more types of problems than just plugging it straight into the calculator. We are going to have some that have our triangles in them. So again, I'm going to write down that phrase SOHCAHTOA, which is so important to remember here for the rest of geometry and so on. Our first problem with our triangles using SOHCAHTOA and our inverse trig functions here, we have a right triangle, which is awesome because we can only do trig functions with a right triangle. We have point A, point B, and point C, and we have the side lengths of 6 and 12. So we're going to find the degree measure of both of our acute angles, so both A and for C. All right, so I'm going to start with A, but it does not matter which one you start with. All right, so to solve for angle A, I'm going to do this one in pink. We have our 3 steps, our setup, our substitute, and our solve. But before we can set up, we need to know which trig function, or rather which inverse trig function we're going to use. So from A, we want to identify which side is our opposite, which side is our adjacent, and which side is our hypotenuse. So from A, our opposite side, or the side furthest from, the side not touching angle A, is going to be this side, CB, at 12 units. Since it's the opposite side, I'm going to draw a pink O. From angle A, our adjacent side is going to be the leg that is touching the leg that is next to the leg that is adjacent to angle A. We know it is a leg if it also touches that 90-degree angle. So our adjacent side is going to be this AB, so I'm going to label that with a capital A for adjacent. And then finally, our hypotenuse is our longest side, or the side opposite from our 90-degree angle here. So I'm going to label that with an H. All right, so from angle A, we know our opposite side and our adjacent side. So we want to find a trig function that has our O and our A in it. So both O and A are in our tangent function here in our TOA. So we are going to use tangent. First, we have to set up. Our setup steps are going to look very similar to one another. So we're going to use our trig function of tangent, show that we're doing the inverse, open our parentheses, and then write our ratio. Our ratio for tangent is opposite over adjacent. So opposite over adjacent. And that is going to give us that unknown angle of A that we are trying to find. Step 2 is to go ahead and substitute in what we know. So we're still using tangent inverse. Our opposite side, our O, is going to be 12. And our adjacent side is going to be 6. All right, so now we're going to go ahead and plug that into the calculator. So we have the inverse of tangent is equal to that fraction that we found, which is 12 divided by 6. Close our parentheses. We can see here that this degree is 63.43. Since that 4 after the 3 is less than 5, we're not going to round up here. So for step 3 solve, we found that angle A is equal to 63.43. All right, so we found angle A. Now we're going to find angle C as well. So for angle C, again, we have to identify what is our opposite, adjacent, and hypotenuse. So from C, our opposite side is the side furthest from, the side that is not touching. The side across from angle C is going to be this side AB at 6 units. So I'm going to draw a yellow O. From angle C, our adjacent side is the leg that is touching angle C, the leg that is next to, the leg that is adjacent to angle C, which is going to be this side CB at 12. So I'm going to draw a capital A. And our hypotenuse is still the longest side, and it is still the side opposite from our 90-degree angle. So our hypotenuse actually stayed the same. Again, the given 2 pieces of information are our opposite and adjacent side, so we once again are going to use tangent. So using our setup, substitute, solve, here we have the tangent of -1, so our inverse here, and then our ratio, so opposite over adjacent. And this time we're solving for angle C. Step 2 is our substitute step. So we're going to plug in what we know. We have tangent inverse. This time our opposite side, our yellow O, is 6, and our adjacent side, our yellow A, is 12 to solve for C. So again, this is when we pull out our calculators. Again, doing the inverse of tangent. This time it is 6 divided by 12 as our ratio. Close our parentheses. And we get to 26.57. And the reason why I say 7 is because the 5 after that is 5 or greater. So we're going to round up. So angle C is equal to 26.57 degrees. All right, and here is the cool part. If we take the 90 degrees from angle B, and we add the angle of A that we found, which was 63.43, and we add that 26.57, we're going to get 180 exactly. And that's a great way to check that we are rounding correctly. All right, let's go ahead and do one more with a triangle, and then we can be done for today. So number 2, we have a right triangle, which is awesome because we need a right triangle in order to do any trig functions. Here we have point E, point F, and point G. So this time we're solving for our 2 acute angles, which are G and F. We are given the side lengths of 65, 72, and 97. All right, so let's do angle G first. So for angle G, again, from angle G, we want to identify our opposite, adjacent, and hypotenuse. So from G, our opposite side, our side that is not touching, our side that is furthest from is going to be this side EF. So I'm going to draw a little O here. From G, our adjacent side is the leg that is touching angle G, the leg that is next to angle G, the leg that is adjacent to angle G. Okay, and that's going to be this side here. Again, we know it's a leg when it's also touching that 90 degrees. And finally, our hypotenuse is the longest side or the side opposite from our 90-degree angle here. So that is our 97. Here we are very lucky to have been given our opposite, adjacent, and hypotenuse. So we could choose any trig function that we want to. We could do sine, cosine, or tangent to solve for angle G. You'll get the same answer no matter what trig function you use. I'm going to go ahead and do cosine just because we haven't done cosine yet. So first we're going to go ahead and set up. So we have our trig function of cosine inverse, and then our ratio. And our cosine ratio is adjacent over hypotenuse. So we have our adjacent side over our hypotenuse. And that's going to give us angle G. All right, step 2 is to substitute. So we're going to plug in what we know. So we still have our inverse trig function. Our adjacent side is going to be that 65, and our hypotenuse is going to be that 97. That's going to give us angle G. Now here we're going to go ahead and plug that into our calculator. So we have cosine inverse of 65 divided by 97, close parentheses. And here we are given 47.92 degrees. And I say 92 because that 4 is not 5 or greater, so we're not going to round up. So we have step 3 solve. So angle G is equal to 47.92 degrees. Now we just have angle F and then we are done, kiddos. So again, we're going to solve for angle F. So the first thing we want to do is decide which sides are opposite, adjacent, and hypotenuse from angle F. So from angle F, our opposite side is the side furthest from. It is the side not touching. It is the side across from angle F. So I'm going to put an O on this 65. From angle F, our adjacent side is going to be the side that is touching angle F, the side that is next to angle F, or the leg that is adjacent to angle F. And again, we know it's a leg when it's touching that 90 degrees. So this is going to be our adjacent side. And once again, our hypotenuse is going to be that longest side, or the side that is across from that 90-degree angle. So our hypotenuse does not change. Again, since we are given all three sides, our opposite, adjacent, and hypotenuse, we could choose any trig function to solve these. It does not matter which one you choose, you will get the same answer. So I'm going to do sine, because we haven't done sine yet. So we have the inverse of sine, and then sine's ratio is opposite over hypotenuse. And that's going to give us angle F. Step 2 is to substitute, so put in what we know. We still have our inverse trig function. Opposite side is 65, and our hypotenuse is still 97. That's going to give us angle F. Now notice our two fractions, those two ratios contain the same numbers. But since we're using different trig function, or rather different inverse trig functions, we're going to get two different answers. All right, so let's go ahead and plug this into our calculator here. The inverse of sine, 65 divided by 97, close parentheses, is going to give us 42.08. So angle F is 42.08. Notice how I rounded up because we had 7.5, and 5 is greater than or equal to 5. And then again, if we take that 90 degrees that we know that angle E has, plus the 47.92 that we know angle G has, and plus the 42.08 that we just found that F has, we get 180 exactly. So that is a great way to double check that you are rounding correctly.